What if I told you that our entire universe, every particle, every force, all the fundamental constants of nature, wasn't just a random accident? What if it was all the inevitable result of one single, incredibly simple idea? Well, that's exactly the proposal behind a theory called unified dynamics. And today, we're going to dive in.
And look, this theory doesn't just make vague claims. It makes shockingly precise calculations. Just look at this table. It predicts some of the most fundamental numbers in all of physics, the masses of particles, the strength of the forces holding atoms together, and it does it with stunning accuracy. I mean, check out those error margins. They're tiny. This is what leads to the theory's most incredible claim.
And here it is. This is the part that makes physicists either get really excited or really skeptical. Unified dynamics does all of this with zero, and I mean zero, free parameters. Nothing is fine-tuned, nothing is tweaked to fit the data. The theory claims that all these numbers just fall out of the core logic, all on their own.
So that brings us to the big question, right? How is that even possible? How can you predict the machinery of the entire universe with no adjustable knobs to turn? Well, to answer that, we have to start by completely rethinking our idea of nothing.
The whole thing, the entire theory, is built on one radical idea, redefining the number zero. This is the absolute key that unlocks everything else we're going to talk about. So normally, we think of zero as, well, nothing, emptiness, a void. But in unified dynamics, zero is pretty much the exact opposite of that. It's an active field. Think of it not as a placeholder for nothingness, but as the fundamental background, the primitive carrier that allows for the very first idea to exist. And that first idea is distinction. That's it, the simple, logical event where something is different from something else. You know, A is not A. In this theory, that single act of making a distinction is the one and only building block for absolutely everything. And that field of zero we just mentioned, it's the stage where this logic plays out.
This one sentence is basically the whole theory in a nutshell. It's the central mantra. We just covered the first part. The field is the zero. So, next up, how do we get some action going on that field? We need the dynamics.
Okay, so you have this field of distinction. How do you get from that simple starting point to the wild complexity of a universe like ours? You need an engine. You need a process. In unified dynamics, that engine is called the master equation.
Now, don't let the name master equation scare you. It's not some terrifyingly complex formula. It's actually an incredibly simple three-step loop. It senses the current state of the field, it makes a decision based on a fixed rule, and then it updates the field. That's it. Then it just does it again, and again, and again.
And this simple engine just keeps looping, acting on that field of zero. A really important rule here is that zero may adapt, but zero may not corrupt itself. Basically, that means while the field can hold all these complex patterns that eventually become matter, the underlying logic, the rule of distinction, always stays intact. The engine just builds and builds on top of it.
So what happens when you let this simple engine run? Does it just create a bunch of random chaos? According to this theory, the answer is no. It inevitably settles down. It converges on a single, uniquely stable structure. This is what's called a fixed point, a state where the process finally comes to rest. And that fixed point is the tetrahedron. This simple, elegant shape, with its 4 points, 6 edges, and 4 faces, is the one stable thing that emerges from the recursion. Why? Because it's the most minimal way to create a closed 3D structure, and it has these really special mathematical properties, like a perfect internal symmetry, that make it the ideal blueprint for reality.
Okay, a simple rule creates a simple shape. That's kind of neat, I guess. But how in the world does that lead back to those insane predictions we saw at the very beginning? Well, this is the payoff. This is where it all clicks together, where simple geometry becomes hard physics. And here is the aha moment. If you just count the boundaries of the different parts of the tetrahedron, something absolutely incredible happens. A face has 3 boundary edges. An edge has 2 boundary points. A point, or vertex, has 1 boundary itself. And this simple 3-2-1 structure maps perfectly to the symmetry groups that define the fundamental forces of our universe. SU3 for the strong force, SU2 for the weak force, and U1 for electromagnetism. It's just sitting there.
The most important part here is that this isn't just a fun analogy. This allows for direct, hardcore calculation. For instance, the Weinberg angle, a really important number in particle physics, is predicted to be a specific ratio pulled directly from this geometry, a value that matches experiments with incredible precision. The theory derives exact ratios for the forces just from counting the parts of this one shape.
So now let's just zoom out for a second. This idea, a theory that derives our messy physical reality from pure, ideal geometric forms, might sound a little familiar. And it turns out the creators of unified dynamics found a parallel that is almost too perfect to be just a coincidence. What you're looking at is a direct one-to-one mapping between the structure of unified dynamics and Plato's philosophy. The ultimate principle of the good lines up with the fundamental act of distinction. The ideal forms line up with the stable mathematical patterns derived from the tetrahedron. And the appearances, the physical world we actually see, line up with the particles that emerge from those patterns. It's like an ancient philosophical idea suddenly found its footing in modern physics.
But for all its philosophical beauty, this theory is all about scientific rigor. It's a machine designed to make testable predictions, and crucially, it's designed to be proven wrong. Its biggest test is an upcoming computer simulation, an F6 lattice simulation, that will try to measure the predicted ground state energy. That's the residual waiting energy of the zero field itself. If that simulation doesn't find what the theory predicts at the exact level it predicts it, then the theory is broken. It's that simple.
Which leaves us with this one final, really profound question. Is it possible that our entire reality, with all its specific constants, its forces, and its structure, is just the inevitable result of starting with the simple difference between something and nothing, and then letting a very simple rule run? Unified dynamics makes the bold suggestion that the answer is yes.